Today, I will be teaching you about honeybee vision. The bee's eye consists of two parts, the compound eye and the oculi. The compound eye is made up of 6,900 facets. On the right, the diagram shows how facets are combined to create the compound eye. A bee is able to see because each facet has 8 cells that respond to incoming light waves. The signals from the facets are then sent to the central nervous system, creating an image. Along with this, the compound eyes are trichromatic. This means that they have 3 photoreceptors. These photoreceptors are responsible for the bee being able to see a combination of colors, which will be discussed in the next slide. Along with being able to see, the compound eye helps the bee with light polarization, pattern recognition, and head-turning responses. The bee also has 3 oculi. These are used to maintain stability, navigate, judge light intensity, stay oriented, and see ultraviolet light. Thanks to their compound eyes, bees have a true color sense. This means that bees can tell the difference between colors. While the visible light spectrum for a human is 300 to 740 nanometers, for a bee, the visible light spectrum ranges from 600 to 300 nanometers for their wavelengths. This means that bees can see a combination of yellow, blue-green, blue, and ultraviolet. This was discovered when Professor Kuhn did an experiment where he trained bees to find a certain color on the color spectrum. He found that bees could most easily find the colors I just listed prior. It has also been found that bees are red colorblind. This was found when an experiment was done where bees had to find a red card surrounded by grays, but they failed to do so, instead mixing up the reds and the grays continuously. Since bees are able to see color, flowers have taken advantage of this. They have created what we know as a nectar bullseye. This allows the bee to find the nectar source more easily. The flowers make this by having 2 colors on their petal, though the colors are not always visible to the human eye, like the middle picture shows, since it is of ultraviolet color. Along with this, the green foliage surrounding the flower helps the petals and the nectar source stand out even more. This is because the foliage is not green to them, but rather dull or gray. White flowers are especially interesting because while they don't seem that eye-popping to us, to a bee they are a beautiful blue-green color. Since bees are red colorblind, it explains why there are little red flowers in Europe. The only reason America has red flowers is due to the other pollinators, like the hummingbird. Poppies are an interesting exception though. Although red, to a bee, they reflect ultraviolet light, making the bee easily see it. Bees' eyes are not only good for color, they also help the bee with visual acuity. An experiment was done where electrophysiological readings were taken every time an item was detected by the bee's eye. It was found that bees can see an item as small as 1.9 degrees, which is the width of one's thumb at arm's length. It was also found that they can detect objects as small as 0.6 degrees, or about 1/3 width of one's thumb at arm's length. Finally, bees' vision allows bees to know how long they have flown for. Bees use objects they pass in the sun or polarized light if the sun isn't out to know the direction and distance they went. Once they know this information, they return to the colony and use the waggle dance to relay the information. However, this sense isn't always perfect. An experiment was done where a bee had to go to a resource they had previously visited, but this time in a semi-checkered tunnel. The checkered panel resulted in the bee flying too long and passing the resource. This was repeated with a horizontal stripe tunnel, and the bee flew too short. Due to these outcomes, it proves that bees use objects they pass to note distance because the checkered was like there was more items, and the horizontal stripes made it seem like there was less objects and items. This allows for the bees to have air and fly too short or too long. That's all I have to discuss today, and thank you for listening.